Welcome to today's demonstration of PowerCalc, the patented software that automatically designs the power distribution system in buildings. We're here today with James Khalil, the inventor, who's demonstrating for Brian, an electrical designer from APG, and also Basharon, an electrical engineer from Atkins Global. So we're going to turn the program over to James, and let's get going.
Okay, so to start the project, basically you need to log into your subscription, what we call it, the container. So when you start with the container here, I'm actually using my company here, Five Design, and you're gonna have a list of all current projects. To start a new project, you're gonna go ahead and click on the button that says New Project, and the name of the project, we're gonna just call it a test. And I guess give it today's date, 18/07/18, and create the project. So now it's setting up the project in the cloud for you, and the first page you're going to get is the project information, which will list for you the project name, and then other information that is pertinent to, in terms of the client, the building, the square footage, whether you're doing a revision or not a revision. So this is here just to as a project control requirement, so you know what you're doing, and you always be able to retrieve it back from the cloud. Now, to start any project, the requirement for PowerCalc to operate is 3 input, and it's per circuit. The 3 inputs are the load KVA, the load type, and the not necessarily any project, but most projects are going to have an MDP, which the program is preset with an MDP already in it. And then it's going to have some distribution panels. Brian, you said like in a hospital you might have a distribution and that sort of things. So you're going to have a series of distribution panels and then panels. So to set up a distribution panel, there is a plus button that next to the distribution panel, so you can insert the panel. You need just to click on it, and once you click on it, it will open up panel number 1. If there's a panel number 2, you go and keep clicking. Now, if we have lighting and power panels, you're going to go to the button that says panels, and you go ahead and add a couple of them for our demonstration right now. Of course, you don't have really to add at a time as you are doing your circuits. Now, and then you have the third type of panels is what we call the building equipment. So, and that will be used for chillers, air handling units, elevators, pumps, whatever mechanically load up one at a time. So, since we opened the building equipment here, let's start from the building equipment. Let's go ahead and name this building equipment. This is air handling unit 1. And the voltage is 480, and it's going to have a fan or a blower, and it is a motor load. Of course, you can select also AC if you want to, and the equipment itself or the motor itself is 480, and then the phase is 3-phase. And let's say that the mechanical give us the mechanical equipment, and it is a 3 horsepower motor. So that's all what you need here to specify the particular air handling unit, and then we're going to go ahead and click on calculate. When you see it calculated the NEC amps, and for the cooling cycle it's 4.8 amps, and the load for the cooling cycle is 4 kVA. Let's say that this particular air handling unit also has a heater in it, so you add the heater. So on if we're adding a heater, and that would be a heater or just a resistive load, again it's 480 and 3-phase, and let's say it's 15 kVA. Enter. And then now the other thing that you need to select in here, see this cell in here says enter H if used in heating cycle. So since the fan is going to be using either cooling or heating cell with an H, so now the system will know that that load also operates during the heating load and the cooling load. So when you figure out your demand, it will take that into consideration. By doing this in here, it's specified for you the feeder down here, and the circuit breaker, and also the disconnect frame fuse size, and then the amps of the fuse size. The equipment is going to be connected, say, to DP1. So you go to Fed From and select DP1. If I select DP1, it will tell me what circuits are available, and I'm going to go ahead and connect it to circuit number 1, submit. So now, as you're inputting the information for a specific piece of equipment and you connect it to the respective switch gear in terms of whether it's MDP, DP1, or even a panel, you can go ahead and connect our distribution system automatically for you, figuring out the feeders, the disconnect, the breaker, and building up the one line diagram for you in the background, and we'll get to that later on. So now, if I click back on DP1, it will show the piece of equipment connected to it. Go to DP1, circuit 1, here's air handling unit number 1, and here's the feeder associated with this piece of equipment and the trip amp. If there is a change down the road that the mechanic will change the horsepower or change the heating, all I need to do is to go back to the air handling unit and select that particular blower to say that they change it from a 3 horsepower to a 15 horsepower and calculate. Then go back to panel DP1. You will see that all the branch circuit and the overcurrent protection device have been updated to satisfy the new electrical requirement. And by doing that, also the feeder for the panel and the overcurrent protection for the panel has been updated. So let's go ahead and start with a panel. So panel 1. Now first of all, we need to set up the panel, meaning that if you need to rename the panel, you can go ahead and rename it. I'm going to go ahead and rename it to LA. Usually I like to use the L for the low voltage if there's multiple voltages in the building, so I can identify panel designation. I can tell that this is the low voltage or the high voltage. I use H for the 480 and L for the 208 120 volts. So we're going to go ahead and set up the panel, whether we need it to be 42. I've provided you with 2 wizards for each of the panels. These wizards are the panel board module wizard and the branch circuit input module wizard. So since we're setting up the panel, I'm going to go ahead through the wizard for setting up the panel. You're going to find that there is about 7 or 8 fields in here. 1, 2, 3, 4, 5, 6, 7 fields, and each is set up. You notice also that in each of the fields, there are cells that are already set on auto. In the start of the project, it's recommended to keep all these calculating every time there's an update or there's a change. It will keep up the calculating or recalculating this information automatically for you, so you don't have to worry about it. In existing condition, if you're making remodeling, yes, you can go ahead and take out. So when you set it up to that particular value, also the system will monitor when you start adding circuits to it for your renovation or remodeling. It will keep monitoring for you and make sure that you're not overloading that particular panel. So, and the general is a voltage hierarchy difference between the child panel and the parent panel. The system will figure out the transformer for you, the transformer size and the primary size and the secondary size for you. The panel port characteristics, I think there's 10 of them. Again, leave them the way they are. It's going to be a low voltage, so it's a 2A, which is the preset or the default value. If it's 480, you can go ahead and change it. And you can change that anytime you want to. You don't have to do it. Really is to select the number of holes because the default of any panel is 6 spaces or 6 holes. So we need to change this, say you want it to be 24. So we're going to select 24 and close and calculate. Okay, so now it opened up the spaces for you. One other thing I forgot to mention when we were at the wizard, the panel module wizard, if you look at the feeder here, again, most of the fields are set on auto or conductor insulation. You have all the insulation that is in the NAC, and you can go ahead and select it for the feeder and change it there. Also, you have the capability to toggle between whether you want the temperature on the conductor to be 75 or the 90 degrees. To toggle between any of these settings. Okay, so we're going to close that. All right, so now we go back to the panel. And remember, in the beginning, I said all you need to specify a circuit is 3 inputs. It would be the load kVA. So let's assume this is going to be a lighting circuit, and it's going to have 1.2 kVA on it. And there's the number of poles, and it's a single pole. And it's a lighting, so you go ahead and select the macro for lighting, which is L. There's also a list of all these macros down here in the calculation block, so you see them in the description for each one of these macros. Now, so I input the 3 inputs that's required. I'm going to say this one here is lighting hallway. Okay, and then click calculate. When we clicked on calculate, the system calculated the branch circuit values for you to number 12 and a number 12 ground in a 1/2 inch conduit. And to maintain a 3% voltage drop, you can 171 feet. And then at the same time, it calculated the feeder to support that load. If you notice that the system was a little bit slow, and it actually, every time you put the circuit that way in the panel board itself, it's going to go ahead and calculate circuit by circuit. To overcome that, we created the wizard, which control panel, and then click on the wizard for the branch circuits. You will have a working screen here for the panel circuits. That's the circuit that we input already, circuit number 1 in panel LA, lighting hallway, and 1.2. The number of poles is 1, and the lighting type or the circuit type is lighting. Now we can go ahead and fill up circuit number 2. So we can go select circuit number 2, and let's say receptacles, CBT, enter load, the 3 inputs in here, 1 kVA, and then select the number of poles from the pull down menu, and then the load type. This is a receptacle, so we're going to go ahead and select the macro R. So now the system is going to demand that load based on the NEC demand for the receptacles, the first 10 kW at 100%, and then the remaining at 50% or 40% for residential and industrial things. Okay, so now circuit number 2 has been filled, and I go to the next circuit. Circuit number 3, enter load description. Let's say it's a pump, and load kVA, it's 4. Select number of poles. We're going to say it's a 3-pole pump, and select load type. Since it's a motor load, we're going to go and select. You can select any of the macros M1 through M4. So select M1, and we can go to the next circuit and so forth until we fill up the panel. Now we're going to go ahead and close and calculate. Go to our panel LA. Here are the 2 circuits that we input through the wizard. Let's go ahead and show the entire panel. So circuit number 1, that's the one we manually input directly into the panel board. And then circuit number 2 is the one we inputted through the wizard, and then circuit number 3, so forth. Okay. Now, again, as we are inputting all these circuits, update it to match the load. So say now we're done with inputting all the branch circuits into the panel. The next thing is to connect that panel to the distribution system. Again, like we did on the building equipment, we go ahead and select from fed from. We can say it's fed. Okay, again, it gives me the available circuits for the MDP to connect that particular panel to it. So I'm going to connect to circuit number 1, submit. Okay, now once I connected the panel LA to MDP, now the system has already figured out by itself that panel LA has a lower voltage and it's set on 208, but MDP is the default is preset on 480. So it realized that voltage hierarchy, and what happened is it went and specified a transform for you automatically. So let me show you how this happens. So prior to the connection, this field here that says transformer down here was blank. The connected load was 6.2, demand load was 7.5. So the nearest size transformer, when we made the connection to panel MDP, the nearest size transformer was the 15 kVA, so it recommended the 15 kVA. If you, as the design engineer of record or the designer, if you really, you know what, you want to make it 30 kVA, all you have to do is go back to the control panel, go to the wizard, go to the general field, and then the transformer, and change that to a 30 kVA. Close and calculate. If I go back to the panel LA, it changed the transformer from 15 to 30 kVA and indicated to you by red background that the auto function has been overridden, and it automatically adjusted the feeder size for you and the panel frame and the overcurrent protection device automatically for you. Now, if there was no voltage hierarchy between the two panels, so if I go back to MDP and set up MDP at the same voltage level, so I can go to the control panel, panel wizard, we go here and change it to 2.8, calculate. Now it's going to go and adjust everything for you based on the new voltage automatically for you, and drop off that transformer, and because now there is no need for it. So if I go back to panel LA, it needs time to update. It should drop off the transformer. I'm sorry, because we actually took out the auto functionality, so you need to go back to the auto to this particular panel wizard and put it back on auto. Calculate. And then go back to panel LA. You see that the transformer is gone, and even the 15 kVA that was before we actually took the auto functionality out. So that's why, again, in the beginning, I said you keep all these fields on auto, and then the system can operate according to your input. And the power distribution system connected the building equipment to a distribution panel. You can also connect the building equipment to a panel. So say again, during the design, you figure out, well, if I connect a particular piece of equipment to DP1, it will overload it, or maybe that's not the correct distribution panel, and you want to connect it to a different panel. So we can go here and say, okay, I'm going to connect it to panel LA. Okay, now what it said in here is the connection is not allowed because of voltage. So basically, it's telling you that the node between the building equipment and the panel that you requested to connect to are in a two different voltage level, and they need to be at the same voltage. Just when you connect the building equipment, they have to be at the same voltage. So we need to basically change this building equipment to a 2.8. Changing this voltage is disconnecting this building equipment from the distribution panel. Please reconnect it again. So now when we change the voltage, it's telling you that I'm going to disconnect you from DP1. So now it's giving you a warning that you've been disconnected, so you need to go ahead, or you're going to go ahead and select panel LA. And now it gave you the available circuits to connect it to. So let's say it's circuit 10. Go to panel LA, and here's air handling unit connected to panel LA circuit 10. It's a 3-phase, and the overcurrent protection device is 60. And then the feeder that is feeding air handling unit number 1. Again, in the beginning, I said that the system will update itself by itself based on the loading of a panel, or moving the building equipment, or any load, moving a load from panel A to panel B, or to find out that the power distribution system is being updated automatically for you. And I also said that in the background, the system is generating the one-line diagram and doing the fault current calculation to date, I guess, in this particular power distribution system on the one-line diagram. Again, go to the control panel. It will give you the startup screen, and then click on the one line. It will display the one-line diagram for you based on the current design. The current design shows panel LA is subfed from MDP, and here's the circuit breaker and the feeder number 1. And you go to the feeder number 1 in the table, and you see it's for number 1 on unit number 1. Let me zoom in, I guess, so you can see. Here on unit number 1 and the feeder number 2, and listed feeder number 2 in the table. If you want the feeders to be displayed on the one-line diagram itself, go to Options, Hide Feeder Table, Apply Changes. It hid the feeder table from the left side of the screen and displayed the conductor sizes on the one-line diagram. Some municipality put the feeder sizes on the actual one-line diagram. What you see in here, or if you notice, something is missing. We were dealing with 2 distribution panels, but they're not here. And the reason for that is, if I go back to my panel, there's two distributions in here that we did not really connect them to the distribution system yet. There's also another way to discover that. We also created the PDT, the power distribution tree. You can click on it, and it will show you what is on the power distribution system and what is not. So you see here that panel LA and air handling unit number 1 is on the distribution system, but unlinked panel are DP1 and DP2. So we need to do something about for that. So we go back to DP1. We can set it up the same way we set up panel LA. Again, if you need more spaces than 6 holes, you can go to the panel wizard and open more spaces if you want to by going here and say, I want 12 spaces. We're going to leave it at 480. Or actually, we need to change it to 2.8 since we changed MDP to 2.8. So to change it to 2. Okay, cool. All right, and keep everything else the same. Or if you want the feeder to be a 90-degree temperature, you can go ahead and select that, and it will specify the 90-degree temperature for you. Same thing on the branch circuits. Leave it at 75, or you can change it to a 90 degrees. Okay, go back to the panel. Now we're gonna add some loads. Of course, I can either link loads to it, or I can directly add the loads here or in the wizard. So I'm just gonna go ahead and add some loads so the feeder will be calculated up here. So let's say it's 12 and it's a RTU, rooftop unit, 3-phase. And it's an AC, and then calculate. Okay, so now added the rooftop unit to the system, and we're gonna go ahead and connect it to MDP. Of course, as you see, I also can connect it to another distribution panel if I want to. The only thing it cannot do is to connect a distribution panel to a lighting panel. The reverse can be done. You can connect a lighting panel or a building equipment to a distribution panel, but you cannot connect a distribution panel to a lighting panel. So you see that the rooftop unit is being connected to DP1, and then we connected DP1 to MDP2. If I go to MDP2, it will show that particular piece of, not the equipment, the distribution panel being connected to circuit map. Now, so let's go to the one line again. You see now that once we connected DP1 to MDP on circuit 2, it already displayed DP1 for us and showed the equipment that is connected to it on circuit number 1. So let's do the same thing to DP2. So let's go back to our panel, go to DP2. Now this time I'm going to link loads to DP2. Okay, rather than inputting the values directly to DP2. So let's say that DP2 is going to have another panel connected to it. So I'm going to set up the panel. And we're going to add just some loads. And it's a 3-phase. And it is lighting again, or heating, whatever. And calculate. And we're going to connect panel 2 to DP2. So now panel 2 is connected to DP2 on circuit 1. Let's go ahead and add another building equipment and connect it to DP2. Let's say it's the elevator, and we can rename it to elevator, but I'm going to keep the name as a building 2, and it's a, select the load type, MTR for motor, and then select the voltage. We need to select it at 208. And it's a 3-phase. And the horsepower, say it's 30 horsepower. Now remember, all these fields are blank. Fields up here are blank until we calculate. Now see what happens when I say calculate in here. It's gonna give us a message or a warning. Or did we change, I guess? Oh, the panel, I guess we haven't selected the fed from. So now let's go ahead and select to be fed from building distribution panel 2. Now distribution panel 2 is still set at 480 by default. So since our building equipment is set at 480, it's allowing the connection. Now, so when I do the select the circuit to become back, now go back actually to DP2 and set up the voltage to the 208. Panel wizard. It will give you, you would need to change the voltage for the following linked equipment before changing voltage of this panel. You will also need to reattach the following linked equipment. It's giving you a list of the equipment that is connected to that default, but now you want to change it to the 208, so you need to go ahead and adjust these values for this particular building equipment. Again, it's keeping tracking of the system. Oh, I need to go and change the building equipment first. Right, so now we need to get out of this one. Go to the building equipment 2. Change the voltage to 8. Okay. All right, so now go back to DP2. Go to the wizard and change the voltage to 208. Now I'll go back to the building equipment and connect it to the panel that we just changed the voltage hierarchy. It's DP2. And I'm going to connect it to circuit number 2. So now everything got adjusted from the circuit breaker to the feeder to the ground to the conduit to the overcurrent protection device. All that got adjusted automatically for you. Let's go take a last look at the one-line diagram, and then I'll open the floor for questions. So now here's your complete one-line diagram. MDP, panel LA, feeds air handling unit number 1, distribution panel 1. Well, we did not connect distribution panel 2. So let's go back here, distribution panel 2. And we're going to connect it to MDP panel, and then circuit 4, submit. So now let's go to the one-line diagram. So here's panel DP2, and here is panel 2 that's connected to it and the building equipment. So hopefully that gave you an idea of what's going on in the background. The other thing that was going on in the background is also the short circuit calculations. So the system will calculate that based on the available fault. So here we assume that it's a 300 kVA, or you can go manually and go here. Okay, and if you have the information from the local power company to say it's 30,000 amps, and we'll go ahead and push calculate. It calculated the fault available at each of these panels. So here's the parent panel LA or 1,213 amps as the parent panel. The child is 4667. So the AIC for the panel, for the parent panel, is 14,000, and AIC for the child panel is 5,000. So it calculated that for you and will display it accordingly on the panel board. Thank you, everybody. We're going to be in Tampa in September, speaking in front of the Engineering Society and the Florida Engineering Society, and we hope to see you there, Brian. So thank you very much.